Hey guys, welcome back to the Skyblock code through series, and today we are finally taking care of the Raycast that we talked about in the last poll. So, if you don't know what a Waila is, because you haven't played Minecraft or whatever, it is just a simple user interface thing that you have at the top of the screen, which is displaying what you are currently looking at. Waila is the short acronym for what am I looking at. So in order to achieve this, first we have to take care of one important thing, which is displaying user interface in front of our 3D camera and world. Not to spend too much time on explaining canvas layers, the only thing you have to understand so far is that by default Godot works with one canvas layer, which is the default one, but you can add other ones based on your needs. A user interface which is static in front of the world, being the player moving around and the camera moving around as well, is a typical example of what a second canvas layer is. I want you to think about this 3D view as the first and default canvas layer. The camera inside it is transforming the 3D world into a 2D view, which is displayed on a 2D screen. Okay, and that's the first one. And now what we want to do is to create a static one, so we will just simply create a canvas layer node. And we will name this user interface, because that will be the user interface. So just to understand how this works quickly, we will begin by creating a simple cross at the middle of the screen, which is going to say where is the Raycast, where it's going to be. So first let's save our user interface and add it to the world so that we can use it later on. So I actually want it to be under the world for it to display in front of the world. So there's another way to do that with the axis, I believe, but at the moment we will just have it under it. So back to the user interface node, we'll just create a center container, right? So if you do want to have more information on user interface, I do have a lot of videos on that dedicated to user interface, and all the other theories which are idle game series, they talk about that all the time. So if you want to know about user interface, go watch this. So here what we will do is just create a center container, and we will change the anchor to full rectangle so that it takes the entire screen. Okay, so this is the screen. What the center container does is that it takes the children and it puts them at the center of the screen. It's that simple. And in order to make a cross, we will use the separator node, which is technically not used to do a cross, but it makes here a horizontal line, and we will make a vertical line as well, and we will change in the layout the size to 16 pixels. Now if we zoom a little bit, we can see that we have a little cross. Okay, so this center container I will rename cross, and now we can start the game and see that we do have this little cross at the middle of the screen. However, we can't move anymore. Well, the camera, at least. The reason for that is, if you remember what we said in an early episode, in the player script, we use the unhandled input method to take care of the camera rotation and player rotation. Unhandled inputs will take any input event which is not consumed by other nodes. And right now this is exactly what's happening. The user interface here is consuming the event because the mouse cursor is in front of it. And it will technically always be, because the cursor is trapped at the middle of the screen. So in order to bypass this, we will just go in the mouse settings of each of our nodes here, and we will change the filter to ignore to make sure that they do not catch the mouse as it is hovering. Here we don't want it to pass either, we really want it to be ignored. So now if we save that and launch the game again, we are finally working very fine. Okay, so this is the first step of making a user interface. The second step is going to be creating that Waila rectangle at the top of the screen, which will show whatever we're looking at. So I will just create a margin container to create some space around it, because I don't want the Waila to be sticked to the top. I want a little space. So I create a margin container, and in the theme overrides, the constant, I will change everything to 8. So we have 8 pixels. Okay, now for the position, we're going to use an anchor to position it easily, and that's going to be the center top. Okay, so this way the Waila is going at the center top, and we can rename it Waila right away. Okay, we will do quite a lot in there, so instead of just having it in the user interface here, I will save it as its own scene. So we're going to save the branch in the singletons, and that's going to be Waila. Okay, so now we can jump into it. And what I want to add is a panel container. A panel container is basically a rectangle that you can style as you wish by modifying the theme, and it will adjust based on the content of that panel. Again, I will add a little margin container because I don't want the text to be sticking to the edges of the container. So yeah, 8 pixels margin around the edges, both outside and inside of that panel container, if that makes sense. After that, I'm going to use a vertical box container, which is going to be used to organize all the children vertically. Okay, so I want the name and the description of the item to show. So the vertical box will take care of organizing those vertically. And from there, all we have to do is to add 2 labels. Okay, one for the name and one for the description. So the first one is going to be name, and the second one is going to be description. So let's add a few basic informations like entity name and entity description longer than name in general. So here we can choose to style the text a little bit by centering those 2 guys horizontally so that they look a little bit better. And we can choose to have this name slightly bigger than the description. So we can achieve that very easily by going in theme of the control node and changing the theme variation to header small. There are a lot of things you can do to make this look more to your likings, but really this is not really the point of this episode, so this will stay like this at the moment. Now if we do start the game again, we can see that we have the Waila token at the top of the screen, which is good. However, it's not supposed to show when we are not looking at something. So let's create some script for this Waila thing. So obviously we want it to be class named Waila, and we're going to make it a singleton exactly like we did it the last time. Okay, now that the Waila is a singleton, I will create a few methods, requests, that we will be able to use in order to control the behavior of the Waila. So the first one that we will create is ReleaseTarget. So ReleaseTarget basically means that we are not looking at anything at the moment, so we want the token to disappear. So here I will just change the visible property to false. The visible property is from the margin container. In the inspector there, you can go in canvas item and see that we have a visible on-off we can use, right? So we want to set it to false so that it disappears. It's that simple. So now by default, we're going to use the ready function at the moment. Ready function, which will just release the target by default. So if we do start the game, we will see that the Waila token is gone. Now, let's make another request, which is hook target. So let's try to organize this. This method, I use an argument in there, which is the key of the item we want to display with the Waila. So what we will do basically is we will fetch the information of the item we want to display, and then we will adapt the Waila token to show that information. So here we'll have an item, let's name it item, which is an item resource. And we just have to go in the item database, fetch the singleton and the data dictionary to go fetch the key. So from there, we do have access to the item, which is, if you remember, here's an item with the key and name and a description, and we are basically using the entire package right now. So what we want to do is to change the content of the label name and description based on whatever the information of the item is. So in the inspector, what we want to change is the text value, and the inspector is telling us that it is the text property, so quite simple at the moment. Just in order to make the editing a little bit simpler, I will pick those two nodes, name and description, and I will access those as unique names so that we can fetch them without having to type the entire path. So first, let's change the name as a label. So this is just safe typing, okay? So we're just safe typing this node to say that it is a label. And we will access its text property, as we said, and we just want to assign to it the item.name. It's really that simple. And in the same logic, we will have the description as label as well. We'll change the text to the item description. A very important thing that we must not forget, because I did during my playtest of this video, is turning this visibility on again by setting it to true. Okay, so technically if we do run the game, nothing happens, okay, because nothing calls on the hook target. So we will simulate hooking a target, which is going to be hooking on a dot block. So if I do run the game, there we can see that we are technically kind of targeting a dot block. Okay, just to make sure that everything works fine, we can change the key and go fetch a stone block. However, this is not how we want the Waila to work. We want it to be using a kind of pointing system to show whatever item we are currently looking. So if we want to achieve this, we do need to create a new node, which is going to be a Raycast3D. So here I'm going in my player node, and I will create a Raycast3D node. So what does Godot say about it? It is a ray which originates from the target position, and that will find the closest collision object. It's literally a ray that will go straight forward until it hits something. And then we will be able to use the information of the raycast hitting something to our advantage. So let's add a little bit parameters to that raycast. So here, let's make it unique, just in case, and see what property we can play with. So we don't want to hit from inside, that's correct. And the target position, well, at the moment it is at the center of this screen right now, of the axis, and we want it to be in the same direction of the camera. So yeah, it's a little bit weird that I picked this one. I think I didn't think about it that much, but anyway. It's going to be -5 for the V value. Something interesting which we can do is assign a color red to that raycast so that we can go in our debug settings in there and make the visible collision shapes activated. It means that when we will play the game, we will see the collision shapes and raycasts. So here you can maybe see the collision of the player. However, the raycast is, as you can see, near the ground, which is not very useful. So what we want to do is just originate the raycast exactly at the position of the camera. The camera here, in its transform, it is around a wheel position, so we'll just change it to 1.8. It's going to be very fine. And we will pick the same for the raycast. Okay, and now there's simply a last problem, if we can say that. So you can see that the raycast is following the player. However, when we look up and down, it doesn't change either. So yeah, we'll just make sure that the raycast is matching the rotation of the camera on the x-axis, just like we did. So we are gonna grab the Raycast3D as a raycast, and we will pick the rotation.x, and we will just assign the rotation.x from the camera, and it will adjust automatically because we already did that script. So now when we look up and down, we can see that the raycast is following as we want. So if I look down, at some point it becomes green because it is colliding with something. So that's what we want to catch, basically. So let's see the documentation of the raycast a little bit to see what we can work with. So we have a lot of properties and methods to work with, but right now we will focus on two. The first one is the method is colliding. The method is colliding is very simple. It will just tell us. It will tell us if we do collide with something. Basically, if it is red or green, based on what we saw. This will be important because it will allow us to know when to hook on a target or when to release a target. Okay. Then the second thing we will use is the get collider. So these methods allow us to get the reference of the node, the object that we are colliding with. So here, in a sense, if you think about the blocks, where are the blocks? The collider will return the reference to that block in the world. Okay. So let's go slowly and just start by creating the Raycast3D script. We will use the process method, so I believe we never used that. It is basically a method that triggers every frame to check something. Basically it is, yeah, just checking everything, nothing to add here. And what we want to do is to check if we are colliding with something or not. So just if is colliding, we want to do something, else we want to do something else. Okay. Now we do have a warning right there because we don't use the delta parameter and we will not use it. Delta is the time elapsed between frames, and honestly we don't need that for the raycast. So first let's start simply by the situation where we are not colliding with anything. In that situation, we just want to go in the Waila, go in the reference of the singleton, and we just want to release the target because we are not watching anything. However, when we are colliding, it's a different story. So here we do know that we do have a collider which we can grab. So let's name this collider. That's an object. And it's just the result of the getCollider method. So we do have a collider, and what do we do with that? So first, we can add a simple check, just in case, because we never know. If the collider is typed block, then we want to do something with it. Otherwise, we will just ignore. So if it is block, we will create a key, okay, which is a string, and that will come in the form of a method from the collider. So we'll have the collider as a block, and we will grab a key from it. So we have different ways to grab the key because it has a key property, but not gonna lie, this key property has an underscore in front of it, which means that it's not supposed to be transformed or read or whatever from external sources. So instead, I will create a new request, which is just GetKey, and that will just return a string, which is the key of our block. We can find this collider as a block and use the GetKey method on it. So now we do have a key of the block that we are watching. And technically what we can do is just send that information to the Waila interface. So we will have waila.ref.hookTarget, and we will send the key to the Waila. So yeah, technically we do have everything we need. So we just have to start the game again and see that we are actually watching stone and we are releasing not watching stone anymore. So we can get rid of those visible collision shapes now and see that it is working without those red and green things. Okay. So we're just gonna make a simple last thing to check that everything works correctly. We will go back to the world, and if you remember, I did remove the random generation here. So I'm just gonna grab the row back again, and based on the result, I will create a dirt or stone block. Okay, so if we have a row, then we want to create 0, 2, and else we want to create a block with 0, 1, and the position. Let's actually bring that here, and we're good. So now we should have a mix of dirt and stone, and yeah, that's dirt and that's stone. That's pretty much it. We are now correctly raycasting the blocks, which is cool. With this thing, we will later be able to destroy blocks and eventually create blocks. So anyway, that's it for today's episode. So as usual, if you did like it, you know all the things you have to do. And I will see you in next episode, which is yet to be defined. So